Okay, I did not make this PowerPoint, some other super person did. Ask Boffin, all about shapes. Properties of shapes. We have a number of sides, number of angles, number of lines of symmetry, and regular or irregular shapes. Right angles, parallel lines. We've got all that kind of terminology that you need to know. We have shapes, triangles, quadrilaterals. What does quadrilateral mean? Yep.
Four-sided shape.
Four-sided polygon. Because a polygon is a shape that's got straight sides and it's two-dimensional. Regular shapes and keywords. Here we have quadrilaterals, so they all have four sides. What shape's that? Might be distorted on the data projector. A square has four sides the same length. It has right angles. How many lines of symmetry does it have? Yep.
4, 5, 6.
6.
4.
4. 1, 2, 3, 4. How do you find the perimeter of a square? Yep. Okay, so you can measure one side, and we've got 1, 2, 3, 4. So we go 4 times that one side, we'd have the perimeter. How would we get the area of a square? Yep.
We get two sides and multiply them by each other.
Okay, so we take one side and that side, multiply them by each other, and you get the area. Alrighty, properties of a square. 4 equal sides, all the same length. 4 equal angles, and they are all right angles. Okay. And 4 lines of symmetry. It's a regular shape because all the angles are the same and all the sides are the same. So that makes it regular. So it's special. This one here? A rectangle. Okay, so this rectangle has how many lines of symmetry? 4. Any advance on 4? Imagine putting a diagonal line. Is it going to work? If you get a rectangular piece of paper and you fold it diagonally, does it fold onto itself?
Only 2.
No, so there's only 2, that's correct. 1, 2. Nice. Properties of a rectangle. 2 pairs of equal sides. So if you're given this side here, you know that that side's the same. In a diagram, you're given this side, you know that that side's the same. 4 equal angles, and they are? Right angles. Yep.
Won't a rectangle also be called a parallelogram?
It's a special parallelogram, yes. 2 lines of symmetry. It's an irregular shape because not all the sides are the same. We've got 2 pairs. What's this one?
Parallelogram.
Right, so what's the difference?
All sides are parallel.
No lines of symmetry. Can't do any fancy folding and have it fold onto itself unless it's a rectangle, which is special parallelogram. 2 pairs of equal sides, 2 pairs of equal angles. Opposite sides are parallel, has no lines of symmetry. Okay, is an irregular shape. Okay, I'm going to go back to our parallelogram and pause for a minute. So I'm creating a parallelogram. So here I'm going to translate an object by a vector. I'm translating this line by that vector. And I'm also, that's cool. So now I can get a segment and pop it here. I'm actually going to colour this one red, I think, so that we can see that one there and this one here are both what? Oops, I wanted that red colour. Red clothes. Okay, so what can you tell me about the red lines? Yep, they're parallel. And the black lines? Parallel. Okay, I'm just going to do some angle measuring. So let's do angle, and we can go here to here to here. We get that angle, 116. And here to here to here, we get that angle, also 116 by the look. And then this one there, and that one there. So what I've done here is I've measured the angles here, 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 and here. So what do you notice? Yep.
The opposite sides have all equal angles.
Yep. So I'm just going to pause. Alrighty. So here I've just coloured those angles so that you can see those two are opposite. I haven't done it particularly well, but you get the general idea. So if I move this, I can play all sorts of games with my parallelogram, right? Yeah, quite cool. What do you notice about those angles? Yep.
Still all the same.
That the green ones are the same, those opposite ones, right? Same number. And the opposite ones, the blue ones, are also the same. 119 there, 0.51, 119.51 there. So that's a parallelogram that I've set up because when I move this, I'm making sure that it's parallel because I did a translation. Now what we want to do, because we're actually looking at area, what's the area here of that rectangle? In square units. So 1 square unit is 1 box. I'm just going to shove that into paint so I can draw all over it. Yep. Pause. Function. Print screen. Back into paint. Control V. Right. Okay, now I can draw on it. So what we've got here is 1 square unit. So how many square units in this rectangle?
45.
1, 2, 3, 4, 5 that way, and 1, 2, 3, 4, 5, 6, 7, 8, 9 that way. So we could go, the shortcut is to go, 9, because there was 1, 2, 3, 4, 5, 6, 7, 8, 9 times 1, 2, 3, 4, 5, which is 45. So what I've done there is that's my length and that's my height, something like that, or width times height, or width times length, whatever you want to call it. You're doing the two different directions, the two different lengths. What's the perimeter of this one? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Am I right? The other way of doing it is 2 lots of 9 plus 5, which is also 28. Okay? This is where we're doing the key learning of the lesson so far. What I'm actually going to do is make a polygon, and I'm clicking on these 4, so I'm actually just making that shape. See that it's shading. The reason for that is I can now show the label, and I'm going to show the value. Now, what did we work out that value was? 45, yeah? Alrighty, so it's 45, so that's sweet. That's the area. So if I move this, here I've got 25, because I've got 1, 2, 3, 4, 5 by 5 is 25. Cool? That's now a square. So what's one we'll have? Nice number, 35? Yeah, cool. Now what I'm going to do is move this. What do we notice?
The area stays the same.
Beautifully said. The area is staying the same. Is the perimeter staying the same? You might notice when I'm changing the height, the area is changing. Yeah? If I go here, I've got 14. If I keep that at 2, I'll still have 14. Those red lines, what is happening?
Getting bigger.
The red lines are getting longer. So the perimeter is getting bigger, but the area is staying the same. So what's the important measure? Here, I'm going to put the height there. How tall is that?
6.
Okay,
Height 6.
so the height's 6. I'm just going to pop in here, show label, and I'm going to put value, just so that, there we go. We've got a 6 there, and here, show label, value, and what are we going to have? 7, nice. So 7 6s are 42, cool. So we've still got our 42, but this is 8.49. So what do we need if we've given a parallelogram to work out the area? What other information do we need to get the 42? What's this one here? That's the height. So this is one thing that pupils get wrong quite often, or students get wrong, is that they're given this, and they want to multiply the two together. But you actually need the height of 6 times 7 is 42 for the area. But for the perimeter, you need this slanted height. So sometimes the diagram will have this, and this, and this. And you've got to select which ones you need for the area and select which ones you need for the perimeter. Okay? Hands up who learnt something? Excellent. All right, let's do some questions on that. Okay, so now work out the area of those 4 now. Alrighty. So the area of this one. What's our base? Or length of the base? How much? 3. So the 3 is this way. And what's our height? 2. So we get 6. The other way of looking at it is imagining that triangle there moving to there. And we've got 1, 2, 3, 4, 5, 6. This one here, what's our base? 4. What's our height? 1. So the area is going to be 4. And the other way of looking at it is imagining that bit there moving there. So you've got 1, 2, 3, 4. Okay? This one here, what's our base? 1, 2, 3, 4. And what's our height? 3. So that's 12. And again, you can imagine you're taking that bit there and you're moving it to there. Does that make sense? Yeah. Okay, so this last one here, we've got a base. What was it? 1, 2, 3, 4, 5. And a height. 1, 2, 3. So 3 times 5 is the same as 5 times 3 is 15. And the other way of looking at it is if this triangle here moved to here, you've got a rectangle. 3 times 5. Make sense? Cool? Okay. So if I was to move this way across to there, my base was 3, so I need to have 3 there. What would the area of that one be? I'm going to just make a few funny looking